Hey everyone, it's Miss Joyce. Today we'll be rewriting fractions greater than 1 as mixed numbers and mixed numbers as fractions greater than 1. We're going to use fraction bars to create the following and answer the questions that follow. So first we're going to place 3 1/2 bars underneath a 1 whole fraction bar. So here, this represents 1 whole. Under it, we are going to place 3 1/2 bars. So here's 1/2. Here's 2 1/2 bars, which is the same as 1 whole. And here's a third 1/2 fraction bar. We can write this in 2 different ways. So the first way we can write this is by counting the number of half fraction bars we've used. We can see we've used 1, 2, 3 halves. So the first way we can represent this is by writing 3 halves or 3 over 2. This means that we used 3 bars. That's why the numerator is 3. And 2 is our denominator, meaning that there are 2 1/2 bars needed to make up 1 whole. So we here have 3 halves. Another way we can write this is a mixed number. So a mixed number means that we have a whole and then a fraction after that whole. Well, if we look, we have 1 whole that's completely made up out of the 2 1/2 bars, and we have 1/2 left over. We can represent this as 1 and 1/2. So this means that 3 halves is equivalent to 1 and 1/2. Let's try another. Here, we're going to place 5 1/3 bars under the 1 whole fraction bar. So here's 1 whole. Now under it, we're going to place 5 1/3 bars. So here we have 1/3, 2/3, 3/3, which is the same as 1 whole, but we need 5/3. So we're going to have 4/3, 5/3. So now we've used a total of 5 1/3 bars. We can represent this in 2 ways. The first way is by counting the number of 1/3 bars we've used. So we've used 1, 2, 3, 4, 5. And so we're going to represent this as 5/3, meaning we used 5 bars. That's why the numerator is 5. And we're using thirds, meaning that 3 of these bars make up 1 whole. We can also represent this as a mixed number. So what we could do is look here. 1 whole is made up of 3/3, and we have 2/3, 1, 2, left over. So we can represent this as 1 and 2/3. This means that 5/3 is equivalent to 1 and 2/3. Great, let's try one more like this. Here we're going to place 7 1/4 bars underneath the 1 whole fraction bar. So here we have 1 whole, and now we're going to place 7 1/4 bars underneath. So we have 1/4, 2/4, 3/4, 4/4, which is the same as 1 whole, 5/4, 6/4, 7/4. So we used a total of 7 1/4 size bars. We can represent this as 7/4. This means that we use 7 bars, and there are 4 bars needed to make 1 whole. We can also represent this as a mixed number. So if we look, we can see that 4 of these bars makes up 1 whole, and there are 3 1/4 bars left over. So we can represent this as 1 and 3/4. Now let's try using number bonds to represent each fraction greater than 1 as a mixed number. First here we have 3 halves, or 3 over 2. So if we have 3 halves, we're going to represent this with having 3 1/2 size fraction bars. We can see that here. We can put 1 whole above it to rewrite this as a mixed number. So if we look, we can see that 2 halves together makes up 1 whole, and we have 1/2 left over. So that means that 3 halves is equivalent to 1 and 1/2. Well, let's try doing this with number bonds. We're starting with 3 halves because that's what's given to us here. We can break this apart by representing this as 1 whole and adding it to whatever's left over. Well, if we want to represent this as 1 whole, we can write this as 2 over 2. We see that because here we need 2 half-size bar pieces to make up 1 whole. So here we have 2 halves, or 2 over 2. We need to add 1 more half to get to 3 halves. We can see that represented here with the 1/2 extra bar left over. If we add it across, we know that 2/2 plus 1/2 equals 3/2, which is what we started with. So that's another way we can check. Let's rewrite this as a mixed number. Well, 2/2 is the same as 1 whole, and we have 1/2 left over. So that means that 3/2 is equivalent to 1 and 1/2, which is the same answer we got when we used the fraction bars. Let's try another. Here we have 4/3. So that means we're going to have 4 1/3 size pieces. So we have 1, 2, 3, 4. If we represent this or compare this to 1 whole, we can see that 3 of these thirds makes 1 whole, and there's 1/3 left over. That means this mixed number would be 1 and 1/3. Let's try doing the same thing but using number bonds. We're starting with 4/3 because that's the fraction greater than 1 that was given to us. We're going to break this apart by first representing what 1 whole would be in here. Well, 1 whole would be 3/3. And we can see that represented here because we are using 3 1/3 size pieces. We need to add a fraction to get to 4/3. Well, let's think. If we have 3/3, we need to add 1 more third to get to 4/3. So now we can rewrite this as a mixed number. 3/3 is the same as 1 whole, and we can put the 1/3 attached to the whole number to make our mixed number 1 and 1/3, which matches what we have up here. Now let's try C. Here we have 10/4. That means we're going to use 10 1/4 size pieces. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, if we're comparing this to 1 whole, we can put a 1 whole up here. Wow, 4/4 makes up 1 whole, but we still have 6/4 left over. That means we can make sure that there's another whole here because there was 4/4 to make up this 1 whole. So we can see that we've used a total of 1, 2, 3, 4, 5, 6, 7, 8 fours to make up these 2 wholes, and we have 2/4 left over. So we can rewrite this fraction greater than 1 as 2 and 2/4. We can check this with number bonds. Here we have 10/4, so we can rewrite this by pulling out 1 whole at a time. Well, we could pull out 1 whole, which is 4/4. Ooh, if we add another whole, which is 4/4, that gets us 8/4. But we're trying to get to 10/4. So we can add, if we have 8/4 right now, we can add 2 more fourths to get to 10/4. So let's rewrite these 4/4 as wholes. We can see this 4/4 is 1 whole, and there's another 1 whole here that gives us 2 wholes and 2/4 left over. So 10/4 is equivalent to 2 and 2/4. Now let's try 15/5. That means we're going to have 15 1/5 size pieces. We have 1, 2, 3, 4, 5, which we know is 1 whole, 6, 7, 8, 9, 10, which is 2 wholes, 11, 12, 13, 14, 15. All right, so here we have 15 1/5 size pieces. Let's see how many holes that is equivalent to. Here we have 1 whole, 2 holes, which is 10/5, and 3 holes, which is 15/5. So that means 15/5 is equivalent to exactly 3 holes. Now let's check with the number bond. Here we have 15/5. So we can rewrite this by pulling out 1 whole at a time. Well, 1 whole is equivalent to 5/5. We can add another 5/5 to get 10/5. Ooh, let's think. What do we need to add to 10/5 to get to 15/5? That would be 5 more fifths. So here, each of these fractions that we're adding is 5/5, which is the same as 1 whole. So we can rewrite this as 1 whole plus 1 whole plus 1 whole, which is 3 wholes. So we can see that 15/5 is equivalent to 3 wholes. Now let's try it the other way. We have 1 and 1/2, and we're going to rewrite this as a fraction greater than 1. So here we have 1 whole and 1/2 left over. If we used 1/2 size pieces, we're going to count to see how many we need. Well, here we need 1, 2 half-size pieces to make 1 whole, and then a third one to match the 1 and 1/2. So we've used a total of 1, 2, 3 1/2 size pieces, or 3 halves. So 1 and 1/2 is equivalent to 3 halves. Let's try that with number bonds. Here we have 1 and 1/2. We can rewrite this 1 whole as 2 over 2, and we're going to add the 1/2 that was left over. 2 halves plus 1/2 is 3 halves, or 3 over 2. So 1 and 1/2 is equivalent to 3 halves. Now we have 1 and 1/3. So we can represent that here by having 1 whole and 1/3 left over. We're going to use 1/3 size pieces and count how many we need to get to the end. We need 1, 2, 3/3 to make 1 whole, and a 4th third to get to the end. So we used 4 1/3 size pieces, which is 4/3. Let's check with a number bond. Here we have 1 and 1/3. We can rewrite this 1 whole as 3/3, and we're going to add this extra 1/3 to get 4/3. So 1 and 1/3 is equivalent to 4/3. Here we have 2 and 1/3. So we're going to have 2 wholes and 1/3 left over. We're going to count how many third pieces we need. Here we need 1/3, 2/3, 3/3 to make 1 whole, 4/3, 5/3, 6/3 to make 2 wholes, and 1 extra third to get to the end. So we use 7 1/3 size pieces, or 7/3. We can check with a number bond by having 2 and 1/3. We're going to add together by rewriting 2/3. We're going to pull out 1 whole at a time. So 1 whole would be 3/3 plus 3/3. This gets us the 2 wholes that we have in front, plus the 1/3 fraction left over. So if we add this up, 3/3 plus 3/3 is 6/3, plus 1 more third is 7/3. So 2 and 1/3 is equivalent to 7/3. Last one, we have 2 and 3/4. So we're going to have 2 wholes and 3 1/4 size pieces left over. We're going to count how many 1/4 size pieces we need. We need 1/4, 2/4, 3/4, 4/4 to make 1 whole, 5/4, 6/4, 7/4, 8/4 to make 2 wholes, and then we are at 8/4. We need 9/4, 10/4, 11/4 to get to the end. So we've used 11 1/4 size pieces, which we can write as 11/4. To write that using number bonds, we have 2 wholes. So we're going to pull out 1 whole at a time. 1 whole can be rewritten as 4/4 plus 4/4. So that's 1 whole plus 1 whole to get the 2 holes in the front, plus the 3/4 left over. So we can rewrite this as 4/4 plus 4/4 is 8/4, plus 3 more fourths is 11/4. So 2 and 3/4 is equivalent to 11/4.